ChemCast.
Hello, in this edition of ChemCast we're going to take a look at electron configuration on top and orbital notation on the bottom. Let's first take a look at some of the symbols we use for doing each of these. First, the number 3 out front. That is our energy level, also called the principal quantum number. That tells us the distance that cloud of electrons is from the nucleus. Second, we have a letter S, P, D, or F to represent the sublevel. That's the shape of the orbital. Then, as an exponent or written out in its orbitals, we have the number 6 here, which represents the number of electrons. Those electrons can be drawn in with arrows, where each arrow is an electron. 2 electrons can fit in each of the orbitals. The orbitals are designated by horizontal lines. This shows 5 orbitals in the D sublevel, and there are 2 electrons that can fit in each one. Now Hund's rule also says that we put 1 electron in each of the orbitals before they start pairing up. This is lower energy and more stable when this is done this way. So we only have 1 that has a pair of electrons, and the other orbitals all have 1 single electron. But our total is 6 here. The orbital notation shows a little bit more detail on where those electrons are than just the electron configuration. Now let's take a look at the electron filling chart. You can find one by doing a Google image search of electron config chart. Alright, here's what it looks like. First, it has the energy levels and what sublevels appear in each energy level. Now, one thing that's going to be important to remember is how many orbitals there are in each of the sublevels. 1 in S, 3 in P, 5 in D, and 4 in F. That's something you're just going to need to remember. Now, this chart shows how the lowest energy levels fill up first. Once we get up to the 3rd energy level, after the 3p, the next lowest energy level to fill up after 3p is the 4s. That's why these diagonal lines are important, because they show that the 4s will fill up before 3d. Then 4p, then 5s, and etc., following the diagonal lines that go down and to the left on the way this chart's written. We can use this chart to look at the electron configuration of any element on the periodic table. Let's take a look at an example. What is the electron configuration and orbital notation for arsenic? First, we got to find arsenic on our periodic table and find out how many electrons we're talking about drawing. Then, when we're doing the electron configuration, we're going to use the format 1s, 2, that 2 meaning to the 2nd power, 2s2, 2p6, etc., using that electron configuration chart that we just looked at until we get up to the final number of electrons. We see that this one ends with 3d10 and then 4p3. Using the shorthand for this, if we use the noble gas shorthand, we take that first section all the way up to 3p6 and substitute the noble gas argon for that. And then the ending you'll see between these two is exactly the same. Now the orbital notation is the same, but instead of writing an exponent of 2 or 6 or 10 in this case, what we're going to do is draw arrows to represent those electrons. Here's what it looks like. Thanks for joining us for this edition of Whitman ChemCast.